9-5 homework with me, Miss Billman. This first one says use the number line at the right for exercises 1 through 7. So the number line is a vertical number line, not a horizontal one. And something to notice, like in number 1, when it says what place value does it show, there are actually 10 little spots. And I'm trying to show you the whole thing because this goes down to the negatives. So from 0 to 1, there are 10 or 9 really in between there, but 10 dashes. So the place value shown on this one are the tenths. Now, it's really important when you're looking at any kind of number line or any kind of math problem for that matter, that you really observe and critically read the numbers that are on there. So if I didn't really look at it, I would probably just start numbering them 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, getting to that 10 and seeing it's a 1. So I'm really going through being thorough to do this. So on one side, I'm going to label it in tenths with decimals. So 0.1, 0.2, 0.3, and so on. Now that is above the origin of 0, so it's all positive. When I go below the origin, that's 0, those are when I'm going to get to negative. Now on the left side of the number line, I'm actually going to be making them fractions. So we'll make sure we look at that. So when we're in tenths and we go to fractions, that's another way to say that, which is great. But this wants it in this, like, if it asks for a simplest form, so something like 5/10, which if I'm just counting, 1/10, 2/10, 3/10, so on. Once I get to 5/10, I'm going to notice that truly in simplest form should be 1/2. So here we go. I'm labeling the right side with negatives. A little bit time consuming, but that's okay because we will use that for the rest of the problems. Also, my handwriting is huge. You guys know that. So this is actually quite a challenge for me to try and write this way. Eek. Number 3 on the left, we will be doing it in fractions. So I write 1/10. Now, normally I would say 2/10, but that ends up being 1/5. 3/10, you can't take that any lower. It's 3/10. 4/10. Now, that's not its simplest form. Its simplest form would be 2/5. And like I told you guys earlier, 5/10, that's 1/2. 6/10, I can't leave it at just 6/10. I could say 3/5. 7/10, I leave it 7/10. Hopefully I remember to move this down. 8/10 is 4/5. 9/10, that's just 9/10. And 10/10, that's 1. Now I'm going to do the same thing with the negatives or the numbers below 0. And the nice part is I already have them done above, so I can copy them. So there's -1/10, and it should be the same thing. -1/5, -3/10, -2/5, -1/2, -3/5, -7/10, -4/5, and -9/10, and then 1. Draw a point at 0.2 and label it W. So 0.2, they could have also said draw a point at 1/5. There you go. Draw a point at -7/10 and label it Z. Perfect. And they could have just said, 0.7. Well, negative. Draw a point at 4/5 and label it Y. There's 8/10. And X will be on -0.9. And I labeled it encircled. On a number line, the rational number -9/4 is located to the left of a 0. So I'm looking at a horizontal number line. The rational number 2 1/4 is located to the right of the 0. Are the numbers opposite rational numbers? So I'm going to go around the world. 4 multiplied by 2 is 8, plus 1 is 9, so 9/4. So 2 1/4 is like saying 9/4. So -9/4 and 9/4, they are indeed opposite rational numbers. when you first look at a mixed number like that, it might be deceiving, where you're like, no, it can't possibly be the same. But when you go around the world, multiplying the denominator by the whole number and then adding the numerator, we actually find out. In this case, it's the same. So we're going to write the opposite rational number. So the opposite is 1/3. This time it's a positive, so the opposite's negative. This one's a negative, so it's positive, and the same goes for that. So this is like having a double negative. I always imagine that negative being distributed to that negative on the inside, making a positive. This one I distribute, it becomes negative 0.75. This one becomes a positive 0.5. And here's a negative 4/5.